Okay, so after section 5.3, now you guys know the connection between antiderivatives and integration. You know that if I want to integrate a function, say if I want to integrate from 1 to 3 of say x squared dx, all I have to do is find antiderivative of x squared, which is 1/3 x cubed. And that's something you learned from your 1a class, and I'm going to review with you today. And then evaluate it from lower bound of 1 to upper bound of 3. So it's going to be 1/3 3 cubed minus 1/3 1 cubed. So plug in 3 and plug in 1 inside. So you get 27/3 minus 1/3, which is 26/3. So you guys learned that from 5.3, the connection between the two of them. Now, basically, here is the importance of antiderivatives. So you calculate the integral, you need to find the antiderivative first to be able to calculate the values, evaluate the values at the two bounds in the antiderivative. So just a quick refresher of what basic antiderivative basic functions were. If you're getting integral of a constant, whatever the constant is, let's just use numbers 5. The antiderivative of 5 is 5x plus c, and this could be any constant. Now, what does that c? That c basically is a vertical shift. And all it says is if I take derivative of this, the derivative of c part would be 0, so that goes away, and derivative of 5x would be 5, so you get this. So it's a general form of the antiderivative for a function. Now, in general, we can say antiderivative of k dx is kx plus c, where k is a constant there. Antiderivative of x dx, of course, is going to be 1/2 x squared plus c, same principle. In fact, if I have any x to the n dx, then it will be 1/n plus 1, x to the n plus 1 plus c. And the fact is, when I take derivative of this part, n plus 1 times 1/n plus 1 gives you 1. So I get x to the n, take away 1 from the power, and derivative of c, of course, is going to be 0. So you just get x to the n. So again, some antiderivatives you learn in 1a, and I'm just refreshing for you guys. Antiderivative of e to the x dx is e to the x plus c, and because derivative of e to the x is e to the x. Antiderivative of, let's say, e to the mx dx would be 1/n e to the mx plus c, because when you take derivative of e to the mx, you get e to the mx. Derivative of e to the mx is e to the mx times derivative of mx, which is just m. So if I want to cancel out that m, I have to divide by an m. So that's how the thinking is. What would be the derivative of this antiderivative? Does it give you the original function back? Going through the journey of your trig functions, antiderivative of sine is negative cosine, because derivative of cosine is negative sine. Antiderivative of cosine, on the other hand, is sine. Again, antiderivative of secant square. We'll talk about more trig functions later, but secant square is tangent. Antiderivative of secant tangent combination is secant. And so on and so forth. There are a lot of these. One of my favorites is antiderivative 1/1 plus x squared, which is tan inverse arctangent. And I think we proved the derivative of arctangent is 1/1 plus x squared. We used techniques in Math 1a to solve that, or show you that. So those are some basic general antiderivatives that you should remember. There's a big list of them in your book that you guys can refresh your minds with. But as I said, it's either a 1a section, or you can go to table on page 403. And they have some more examples there for you to use. So we know the importance of antiderivative, and we know the connection between antiderivative and calculating, evaluating integrals. Now, there are some homework problems that I can help you with some of the problems that ask you to calculate antiderivative, and each one of them involve certain tricks. Now, when you look at the homework problems 5 through 18, it says find the general antiderivative, general indefinite integral, And problems 21 through 46, it says evaluate the integral. What that evaluate is, what it means is because you're actually plugging in the bounds to calculate the function value at those bounds. So it's a definite integral. You're actually getting net value for your functions, whereas problems 5 through 18, you get a family of solutions, family of antiderivatives for the function. So that's a general integral. So just again, doing something like problem number 6. So in 5.4 number 6, it says integral of 4th root of x to the 5th. That's going to be, I'm going to rewrite it in the power form, x to the 5/4. And then based on one of the properties I told you earlier, you add 1 to the power and then take it to the power to that same sum power. So you get x to the 5/4 plus 1 over 5/4 plus 1. It looks ugly at the beginning, but you can clean it up. So it's going to be x to the 9/4 over 9/4 plus c, or 4x to the 9/4 over 9 plus c. So that will be your general antiderivative for 4th root of x to the 5th. That's basically what they want you to do for those. When you look at something like number 10, integral of square root of t squared plus 3t plus 2 dt. Now it feels like, well, what are we doing with the product? Well, technically, all you need to do is distribute the root t. So you get t squared root t plus 3t root t plus 2 root t. And again, I don't like the radical form, so I'm going to change it to the exponent form. So it's going to be t squared times t to the 1/2 plus 3t times t to the 1/2 plus 2t to the 1/2. I'm sensing a power rule here. So I get t to the 2 plus 1/2 plus 3t to the 1 plus 1/2. I'm combining the powers there. And then 2t to the 1/2. Clean up my addition. I get t to the 5/2, 3t to the 3/2, 2t to the 1/2. Now, up to here, it was just algebra. I didn't do any calculus. I just multiplied and then simplified the powers. No calculus yet. At this point, I'm going to do the calculus, which is antiderivative of the power rule. You get 1 over 5/2 plus 1, t to the 5/2 plus 1. 3 over 3/2 plus 1, t to the 3/2 plus 1. 2 over 1/2 plus 1, t to the 1/2 plus 1. And plus c as a general antiderivative. So I get 1 over 7/2, t to the 7/2, 3 over 5/2, t to the 5/2, 2 over 3/2, t to the 3/2 plus c. And then I just do my algebra again. 2 over 7, t to the 7/2, 6 over 5, t to the 5/2, 4 over 3, t to the 3/2, and so forth. So that will be your answer for that one. Now, if you have to do something like 11, which I don't know if I signed that one or not, but no problem. It's integral of 1 plus root x plus x over x. This one, you have to split the integral. 1 over x, root x over x over x. Now, root x over x is going to be x to the 1/2 minus 1 because the denominator. 1 over x, x to the negative 1/2 plus 1 dx. Of course, you're assuming x is not 0. Antiderivative of 1 over x is natural log of x, an absolute value. Antiderivative of x to the negative 1/2 is x to the negative 1/2 plus 1 over negative 1/2 plus 1, x plus c. So you have natural log of x plus x to the 1/2 over 1/2 plus x plus c. It is natural log of x plus 2 root x, if I want to write the radical form, plus x plus c. Again, all of these you have to write them in the power. And basically, that's the most involved process you know so far, power rule. Okay. Number 15. We have integral of 2 plus tan square. And again, I'll talk about tricks to integration soon, but this is just a pretty straightforward. The only problem with this one is tan squared, I don't have it in the table of my antiderivative for basic functions. So we don't have tan squared there, but I can rewrite tan squared as secant squared minus 1. If you guys remember. So I can rewrite it as 1 plus secant squared d theta. Antiderivative of 1 is theta. Antiderivative of secant squared is tan. So this is how you're approaching it. So you have to use, sometimes you have to use trig identity and know that tan squared is secant squared minus 1. Okay. Now, to go through the definite integrals that they give you, the list of definite integrals that they give you, you will see that you see a lot of power rules again there, a lot of the ones that you have to distribute the power and such. Let's do number 26 together. Now, this is now actual evaluation ones. So I would recommend you to first FOIL it out. Antiderivative of t is 1/2 t squared. Again, the power is 1, so you get 1 over 1 plus 1, which is 2. T to the 1 plus 1, which is 2. 2/3 t cubed, 1/4 t to the 4th. And I'm evaluating that from -1 to 1. So I get 1/2, 1 squared minus 2/3, 1 cube plus 1/4, 1 to the 4. So that's a positive part. Minus 1/2 -1 squared minus 2/3 -1 cube. I think I need some space here. Plus 1/4 -1 to the 4th. So I have a 1/2 minus 2/3 plus 1/4 minus 1/2 minus 2/3 plus 1/4 minus 1/4. So 1/2 and 1/2 cancel out, 1/4 and 1/4 cancel out. So my end result is -4. And that's how you calculate those definite integrals. Okay. So something like 33. One to 2 x over 2 minus 2 over x. Question that sometimes people ask is, why don't you put the plus c when you do definite integrals? Because when you do definite integrals, you don't get a family. So you just need n. You remember the fundamental theorem calculus? You just want n antiderivative. You don't need all possible antiderivative. You don't need the family of solution. Just n antiderivative. And that's why you don't put the plus c there. So antiderivative x over 2 is 1/2 times antiderivative x, which is 1/2 x squared. And antiderivative 2 over x is 2 natural log of x. 1/4 2 squared minus 2 natural log of 2 minus 1/4 1 squared minus 2 natural log of 1. 4/4 is 1, natural log of 2, leave it as is. And natural log of 1 at the end is 0, which we don't care. So 3/4 minus 2 natural log of 2 is your final answer for that. Okay, and that's how you approach most of these problems. Again, if there are any specific question about any other one of these, feel free to ask me and I will make a video solving those for you. Now, there is a concept that is introduced in this section, which actually we talked about in the previous section, and that is the concept of net change. Basically, what net change theorem says, and it is something probably relatively obvious to you from what we did in the past, but net change theorem says that if you integrate a rate, you get the net change. So it basically says the integral of a rate of change is a net change. So integral a to b of some function that is the rate of some change. Now, I don't like this in notation because it confuses you with the fundamental theorem calculus, but this one is specifically for a function that a rate function. And then you get fb minus fa, and that's the net change. What net change is, it's, if you remember, if you, let me explain it this way. If you start from here and you go in the positive direction, that means your velocity is positive. And then you decide to go backwards in a negative direction, your velocity is negative. Then you go forward in positive direction, your velocity is positive. Then you backward in a negative direction, velocity is negative. Net change is really the distance from where you were to where you end up. That's a net change. So this is the net amount, the distance change, the net distance. You were here, now you ended up here. So if I look at it in the horizontal direction only, this is where I am. This is like a graph of back and forth. So if you start pacing front and back, back and forth, back and forth, back and forth, where you are and where you were initially, the distance is net change. Whereas the total change will be the total length, the path that you went. That would be the total change, not the net change. So total change would be integrating a absolute value of f prime of x dx. That would be the total change. Total distance traveled, total amount. Net is just the displacement. Net is just the amount difference. So if you give me a velocity function, in particular, if v is a velocity function, v of t, let's call it, integral of v of t dt is net displacement. But integral absolute value of v of t dt is total distance travel. Okay, so that's, let's do a quick homework example from this. I think this requires a little bit more explanation, maybe through some of the homework problems. So let's do problem number 59 from the homework. So 59 says a velocity function. A velocity function in meters per second is given for a particular particle moving along a line. Find the displacement, total distance traveled during this. So two things, the displacement and total distance traveled. So the velocity on 59 is v of t is 3t minus 5, and t is somewhere between, t goes between 0 and 3. So the net displacement is integral from 0 to 3 of 3t minus 5. Basically, that's all. Use that formula. So it's going to be 3/2 t squared minus 5t, evaluated from 0 to 3. 3/2 9 minus 5 times 3 minus 3/2 0 plus 5 times 0. So you get 27/2 minus 15, which is negative 3/2. In a way, what it says is the object actually goes backwards on the from where it is. So that's a net displacement. Okay. Now, if I want total distance travel, I have to integrate 0 to 3 of absolute value of 3t minus 5. Now, this is tricky because 3t minus 5 looks something like this. So there is a cutoff. It's negative before 5/3 and it's positive after 5/3. So I have to split the integral to 0 to 5/3. From there, I have to change it to negative. Why? Because from 0 to 5/3, the function is negative. It's below the x-axis. So I have to make it positive. So I multiply the function 3t minus 5 by a negative. That would make it a positive, hence the absolute value, dt. And then from 5/3 to 3, just 3t minus 5 was good because from 5/3 to 3, you're already above the x-axis. So you negate the part that's below the x-axis to make it positive and keep the part that's above x-axis alone. So I get negative 3/2 t squared plus 5t. That goes from 0 to 5/3. 3/2 t squared minus 5t, and that goes from 5/3 to 3. Negative 3/2, 25/3, squaring that, plus 5, 5/3. Remember, your answer has to be positive. So if you don't get a positive answer, you did something wrong. Minus negative 3/2 times 0 squared plus 5 times 0. That part just takes care of this. And then continuing, plus 3/2 3 squared minus 5 times 3 minus 3/2 5/2 squared minus 5/3 squared minus 5 times 5/3. So I get negative 75/6 plus 25/3 minus 0 plus 27/2, sorry, minus 15 minus 75. Oh, sorry, this is 25 9th. 18. 75 18th again. Minus 25/3. So negative 75 18, negative 75 18 is 75, negative 75 9. 25/3 and positive 25/3 is 50/3. And then we have minus 50. And there's a Okay, let me just double check my work here, make sure I did this correctly. Everything right. Okay. And then plus 27.5. So from here, we can simplify this as 150 minus 75, you get 75/9 minus 3/2. It's going to be 150 minus 45/18. It is 105/18. Divide by 3 top and bottom. Obviously, you get 35/6. And that's your total distance traveled. Numbers were a little bit uglier than expected, but that still worked out okay. Okay. Now I want to do problem number 61, which is now works with acceleration. And I think that would kind of help you understand how to deal with those problems. In 61, it says the acceleration function and the initial velocity are given. And then the velocity, find the velocity at time t and distance traveled during the given time interval. Total distance traveled, not displacement. So first we have to find the velocity and then the total distance traveled. So this is 61. They give you acceleration. Remember, acceleration is derivative of velocity. So that would be your rate. Remember, the rate is acceleration now. V of 0 is 5, nice. And t goes between 0 and 10. All right, so let's integrate to get V of t. We have to integrate A of t, which is integral of t plus 4, which is 1/2 t squared plus 4t plus c. And that c is really what makes a difference. Now, V of 0 is 5. So 5 is 1/2 t 0 squared plus 4 times 0 plus c. So c would be 5. So now I have a nice formula for V of t. It's 1/2 t squared plus 4t plus 5. So the total distance traveled would be integral of absolute value of Vt dt, which is going to be integral of absolute value of 1/2 t squared plus 4t plus 5 dt. And you integrate that from 0 to 10. Which is 1/2 integral from 0 to 10 of t squared plus 8t plus 10 dt. Again, 0 to 10. Now, this function from 0 to 10 remains positive. So the function from 0 to 10 remains positive. It never has any negative parts to it. So its absolute value is the same thing as the function itself. Because it's always positive. So antiderivative of t squared is 1/3 t cubed plus 4t squared plus 10t from 0 to 10. So it's going to be 1/2, 1/3 10 cubed plus 4 10 squared plus 10 times 10 minus 1/2, 1/3 0 cubed plus 4 times 0 squared plus 10 times 0. Of course, this part is all 0. For the top, I have 1/2, 1,000/3 plus 400 plus 100 is 1/2, 2,500. Which is going to be 25, 12, 50, whatever the units are here, in this case, meter. That's how you approach this. So I hope this little lecture on this topic and some of the problems we did a lot of problems on this topic. So I hope that helped. Remember, net change is integral of the rate, and like for the displacement, net change is the integral of rate. For displacement is integral of the velocity. For total distance is an integral of absolute value of velocity, to keep everything positive as you're calculating the integral. Okay, I hope this helped. And again, I'm going to make a video for substitution method in 5.5 and the area between curves in 6.1 for you guys. I'm going to upload it for you. Okay, I hope you guys enjoyed this lecture.